Hi, welcome back to the channel. In this lesson, we'll see how to find the area between a curve and an intersecting line. As a prerequisite to this lesson, you need a lesson on integration and how to find the area within a curve. In case you missed those lessons, please do not hesitate to look at the description below, and we have also placed a link up here to help you get access to that lesson. That said, let's get into class. Now, like I said, we'll be looking at how to find the area between a curve and an intersecting line. We'll use this question that says we should find the area between the curve y is equals to 25 minus x squared and the straight line y is equals to x plus 1. Now, here is a curve and here is a straight line. Here is a curve of y is equals to 25 minus x squared, and here is a straight line of y is equals to x plus 13. There are two unique things I want us to note about this area. The area is actually bounded by the curve and the straight line. That is, it is this portion between the curve and the straight line. And two, both the curve and the straight line intersects at 2 points. Now, the first thing I want us to deal with is the point of intersection. This is the point where the y for the curve, where y is equals to 25 minus x squared, is same thing as the y for x plus 13. That is, if y here is y1 and y here is y2, that will be the point. That will be the point where y1 is equals to y2. That is, I can easily equate both equations so that 25 minus x squared will be the same thing as x plus 13. We can collect like terms. Let's move x and 13 to the other side. This becomes 25 minus x squared minus x minus 13 is equals to 0. So that my minus x squared minus x, 25 minus 13 now becomes plus 12 is equals to 0. Now I have minus x squared minus x plus 12. I'll be factorizing. I can factorize them using factorization method. We'll multiply my minus x squared by 12. That becomes minus 12x squared. Now, what are the products or what are the factors of minus 12x squared? That will be same thing as minus x. That is, that will come from minus 4x times plus 3x. So multiplying both of them, I'll come up with, or substituting both of them in place of minus x, we'll come up with minus x squared minus 4x plus 3x plus 12 is equals to 0. Obviously, minus x becomes a factor. This becomes x plus 4. And here I have plus 3 as a factor into x plus 12. X plus 4 rather, sorry, x plus 4 equals to 0. That x plus 4 now will be equals to 0. This implies that my x will be equals to minus 4. Minus x now plus 3 is equals to 0. This implies that my minus x is equals to minus 3, which also implies that x now will be equals to 3. That means my area, or both the curve and the straight line intersect at minus 4. I can tag this point minus 4 and I can tag this point 3. Now, the next thing which we should observe is the area bounded by this curve. First and foremost, I want us to see the area bounded by the straight line. Then we'll see the area bounded by the curve. Now, the first thing is the area bounded by the straight line. If you look at the straight line here, this is the area between this point. Here is my point of minus 4, and here is the point of my point of 3. So this is the area bounded by the straight line. Now let's see the area bounded by the curve. In the same vein, here is the area bounded by the curve. Now, if you look at the area bounded by the curve and the area bounded by the straight line, you see that the area that is requested from us, area here, is just subtracting the area bounded by the straight line from the area bounded by the curve. Let me tag the area bounded by the straight line as A1 and area bounded by the straight line as A2. Obviously, this is just saying A now is equals to A2 minus A1. That's the area bounded by the straight line and the curve. Now, to calculate the area bounded by the curve, we'll be taking the integral of the equation of the curve, which is the integral of 25 minus x squared, ranging between 3 and minus 4. Because our point we got from our earlier calculation, here is minus 4 and here is 3. Now this is minus the integral of the area under the straight line, that is x plus 13, ranging between 3 and minus 4. Now we can put both of them together so that this is the same thing as saying area of here is 3 minus 4 into 25 minus x squared minus x minus 13. I've just simply subtracted both of them. Let's use another slide so that my focus area now will come from the integral of 25 minus 13, that's 12, minus, that's minus x. Okay, that will be 25. 25 minus 13, that's 12. That will be 12. That will be 12 minus x minus x squared with respect to the x. With respect to the x, ranging between 3 and 4. So that will be 12 minus x squared with respect to the x, ranging between 3 and minus 4. This is equals to area A. So that my area now, A, will come from, let's integrate. On integrating, 12 will become 12x from our lessons on integration, minus x raised to power 1, that become x plus raised to power 1 plus 1 over 1 plus 1, minus x now raised to power 2 plus 1 over 2 plus 1, all ranging between 3 and minus 4. And so that my area now will come from, area will be equals to, with 12x minus x raised to power 2 over 2 minus x raised to power 3 over 3, all ranging between 3 and minus 4. So that my area A now will come from, A will be equals to 12 into 3, that's 12 into 3, minus 3 now, all squared. In place of x, I'm only putting 3, minus 3 again, raised to power 3 over 3. Now minus, we'll repeat the same thing and we'll substitute 4 for x, raised to power 4, minus 4 raised to power 2 over 2, minus 4, oh, this is minus 4, sorry, this is minus 4, not just 4. This is minus 4. This is minus 4. This is minus 4 again, raised to power 3 over 3. And so that my area A, of course, will be the same thing as 12 times 3, that's 36, minus 3 raised to power 2, that's minus 9 over 2, that's 4.5, that's 4.5, minus 3 raised to power 3 divided by 3. Obviously, one of the 3's will cancel. I'll be left with 2 3's. That's minus 9. Then I have minus again here into 12 times 4. That's minus 48. Minus 4 raised to power 2. That becomes positive 4. Divided by 2. That's become positive 16. Sorry. Divided by 2. That's positive 8. That's minus 8 because there's a negative sign outside. I have minus outside, but I have minus raised to power 3 here. That becomes negative times the minus outside. That becomes positive. 4 times 4, that's 16. 16 times 4 again, that's 64. That's 64. That's 64 over 3. 64 over 3, I just want to put it into indices or into decimals. 64 over 3, that's 21.3. That's 21.3. 21.3. Also, I'll have A now will be the same thing as now 36 minus 4 points. Let's use our calculator. That becomes 36 minus 4.5 minus 9. That's equals to 22.5. That's equals to 22.5. now minus. Now we have negative 8. I prefer to start with the 21 that is positive. 21.3, 21.3 minus 48 minus 8. That's equals to minus 34.7. So that at the end of the day, we'll be saying that our area will be equals to 22.5 plus 34.7. So that the area will be the same thing as 22.5 plus 30, that's 22.5 plus 34.7 equals 57.2. That's 57.2. 57.2 units, depending on the units of the graph. It could be in centimeters, it could be in meters, it could even be in kg, depending on the unit of what is being measured. Our area is 57.2. Now, with this, I hope you have an idea or you understand how to calculate the area bounded between a curve and an intersecting line. Thank you for staying with us and see you in our next class.